This is R.D. Sharma Solutions, Class 11, Chapter 28, Introduction to 3D Coordinate Geometry. Exercise is 28.3. The first question is, the vertices of the triangle are A, B, C. 3 points are given. The internal bisector of angle A meets BC at D. Find the coordinates of D and the length AD. Let me explain you the question first. This is a triangle and the vertices are given. Now there is an internal bisector of angle BAC, that is angle A, and this internal bisector, these two angles are equal. Now this meets D in BC at D. So we have to find out the coordinates of D and also the AD length. So how do we do this? We will use the internal division or sector formula. Before that, we will use the property of a triangle. See, AB, AC, BC we can find out. We know the coordinates and coordinates. So AB, AC and BC we can find out. AB will be 5 root 2, distance formula. 5 minus 1, 4, 4 minus of minus 1 means 5, and 6 minus 3, that is 3. So under root and square and add. Then AC also you can find out. Now AD is the internal bisector. So there is a property that whenever we have an internal bisector of an angle, then the point it touches on the opposite side, the ratio of that division is equal to the ratio of the side holding the angle. That means if I make an angle bisector here, so these two sides, the ratio will be equal to the holding angle, that is these two sides. That is, if I just give the names here, B, C, A, so and this intersection point is D, so BD by DC equals AB by AC, okay? So same thing, sides we have just found out. So BD by DC equals AB by AC, which is 5 by 3. AB, AC, 5 root 2, 3 root 2, so 5 by 3. So now we know that BD by DC equals 5 by 3. So we have a ratio of internal division. So there is a line, you can assume like this, and the internal ratio is 5:3. That is, the point divides the line BC internally in the ratio 5:3. So the point B and C we already have. 1 minus 1, 3 and 4, 3, 2. 5, we know that this is M is to N, and you can take it as M1 is to M2. So M is to N, which we earlier knew how to do this. This is 5:3. So let me just write the formula here, so that you just remember that this X, Y, Z, these three coordinates of point D, how to compute it. So X will be, if I take M1, M2 rather than M and N, you can take any of these, because in your book it is given M1, M2, so I am taking M1, M2. M1 X2 plus M2 X1 by M1 plus M2. So either you take it as M or N, or you take it as M1, M2. Y will be, I am just taking it as M1, M2. As I said, your book has mentioned M1, M2, so I'll just go with this. So you have M1 Y2 plus M2 Y1 divided by M1 plus M2. This will be your Y coordinate, and the Z will be equal to M1 Z2 plus M2 Z1 by M1 plus M2. I hope you got this. So M1 and M2 are known, 5 and 3. That is M or N, which I earlier stated. M1 and M2, M1 you take it as 5, M2 you take it as 3, and now you have X1, X2, X3 as X1, X2, X1, Y1, Z1 and X2, Y2, Z2. So this is point B is X1, Y1, Z1, point C is X2, Y2, Z2. Now just apply here. So I'll just show it here, 5 with 3. 5 into 4 and 3 into 1. Add them, divide by 5 plus 3. This is your X point. Then 5 into 3 and 3 into minus 1. Add them, divide by 5 plus 3. 5 into 2 and 3 into 3 divided by 5 plus 3. So you have D point. So D point, the coordinates are known. This is the first part of the answer. When the D point is known, A is also known. The coordinates of A and D are known. So you can find out the distance between AD by distance formula, 5, 4, 6 and these D points. So the distance will be under 1530 by 8. So now the things are clear. So we'll apply directly. The point C with Z coordinates 8 lies on the line segment joining the points A, B. Find its coordinates. So the situation here is, we have a line, this line, and just assume everything in 3D. It's not 2D. Because this is a screen, I cannot show you 3D. Just assume it to be 3D. A point is 2 minus 3, 4. B is given as 8, 0 and 10. 8, 0 and 10. Now where we have a point which is in between there, whose Z coordinate is 8. I don't know about X and Y, but only if it is Z is also given, I can find out the solution. So first and second I leave. I don't worry about. Then the third point is 8. It's somewhere in between A and B, the C point. So what ratio it will be? It will be lambda is to 1. So just assume it to be that this point is dividing this line into lambda is to 1. Now you can assume it to be k is to 1 because earlier we have been doing k is to 1, but lambda is to 1 because it's a 3D, just take it as lambda is to 1. So 8 into lambda plus 2 into 1 divided by lambda plus 1 is the x coordinate. 0 into lambda and minus 3 into 1 divided by k plus 1 is the y coordinate. Then 10 into lambda, 4 into 1, add them, divided by lambda plus 1 is the third point, that is the z point, 8, which is given already. So now this point is already 8, so why not to equate it? So when you equate it, lambda will be 2, so lambda is there, put it in all these 3 points, you will get 6 minus 1 and 8. Question number 3. Show that the 3 points A, B, C are collinear and find the ratio in which C divides AB. A, B, C are collinear and find the ratio in which C divides AB. So the point is already given. So we have A, B and C is in between somewhere. So we just have to find out lambda is to 1. That is lambda is to 1, we'll assume it to be. So C is somewhere in between. We don't know the position. Collinear means in the same line. They lie in the same line. Whether C is internal or external, I don't know. We don't know right now, but we'll surely find out. A and B point just mark. C point is already given. The C point is minus 4, 1 and minus 10. So what we have to do, this is lambda and 1. So just lambda into minus 1 plus 1 into 2 divided by lambda plus 1 is the x point is equal to minus 4. Then second one is 2 into lambda and 3 into 1, add them, divide by lambda plus 1, this is the second point, and minus 3 into lambda and 4 into 1 divided by lambda plus 1 is going to be the third point. So either you use any of these, lambda from one equation only you will get lambda. So every time you take these 3 equations, you will get lambda as minus 2 only. So because previously only 8 gave us the lambda. So lambda is minus 2. But minus 2, what does it mean? It means negative. That means it's not internal division. C does not lie between A and B. It's somewhere outside. K is to 1 is, or lambda is to 1 is, or lambda is to 1. It is negative. That means it is external. C is not here. C is somewhere here. That is, this is A, this is B, and this is C. So we have CA by CB, CA by CB, or you can say AC by BC equals 2:1. I hope you got the idea, this 2:1, but you have to add externally here because you got negative. Wherever you get negative, you have to write externally. Question number 4. Find the ratio in which the line joining 2, 4, 5 and 3, 5, 4 is divided by this YZ plane. YZ plane. Remember, on YZ plane, x is 0. In ZX plane, y is 0. In XY plane, Z is 0. So we have A and B point, we have in between a plane, and let me join these lines, and this line will intersect this plane somewhere, and that intersection point we are interested in. And one more thing, this YZ plane is internal or external? I don't know. We don't know. So we have to find it out. So this point, let us assume that it is internal. Let us say that this point is PB. So AP by PB, what it will be? So you know how to do this. Assume it to be lambda is to 1. If it is negative, it is external. If it is positive, it is internal. P is inside somewhere A and B. So lambda is to 1, it is dividing. Again, YZ plane means x is a 0. X coordinate is 0. Whatever comes, just put x as 0. So x, y, z we can find out. You know how to do this by the sector formula or section formula. So lambda is 3 into lambda, and 2 into 1 by lambda plus 1, then 5 into lambda, 4 into 1 by lambda plus 1, 4 into lambda and 5 into 1 divided by lambda plus 1. These are our 3 coordinates. But clearly given YZ plane x is 0. So put 3 as 0, lambda will be minus 2 by 3. That is lambda is to 1 is minus 2 by 3, but it is lambda is to 1 is 2 by 3, no doubt. But the scenario here is it's negative. So the plane is not between A and B, it's outside A and B. I hope you got the idea. A and B is here and the P point, that plane is outside. This is the scenario. A and B, this plane is not in between. So PA by PB is 2 by 3. PA by PB. Question number 5. Find the ratio in which the line joining the points 2, minus 1, 3 and minus 1, 2, 1 is divided by the plane x plus y plus z equals 5. Now the scenario remains the same. So we have 2 points. So we have a plane here, and I don't think this is a plane, I made it something else. Anyways, so we have this concept is important, right? I always say, I save myself from my handwriting and drawing by saying that concept is important. So A and B, these are the points 2, minus 1, 3 and minus 1, 2, 1. Now it is intersecting in this plane. This is a point C. Now the equation of the plane is given, remember. So this point C divides AB into lambda is to 1. So now you can find out the point C. See, 2 into 1 and lambda into minus 1 divided by lambda plus 1 is your x point. Minus 1 into 1 and 2 into lambda divided by lambda plus 1 is second point. 1 into 3 and lambda into 1 into 3 and lambda into 1 divided by lambda plus 1. Now these 3 points which we found out is lying on this plane because the equation of the plane is given. So in the place of x, in the place of y, in the place of z, just replace in this equation x plus y plus z equal 5. So when you put it here, you will get lambda. Lambda will be minus 1 by 3. This lambda minus 1 by 3, whenever you find negative, it's external. 1 is to 3, external. Question number 6. If the points A, B and C, the points A, B, C are collinear, find the ratio in which C divides AB. So almost same thing we have already done. Same thing, right? So we have A, B, C, C is in between somewhere, and we have coordinates of A, we have coordinates of B, coordinate of C. We have to just find out lambda is to 1. So we have 3, 2 minus 4, B is 9, 8 minus 10, and C is 5, 4 and minus 6. 5, 4 minus 6. Now this is lambda is to 1. So how to find it out? 9 into lambda plus 3 into 1 divided by lambda plus 1 is x. 8 into lambda 2 into 1 divided by lambda plus 1 is y point. And minus 10 into lambda plus minus 4 into 1 divided by lambda plus 1 is the third point. Now just equate this with 5, 4 minus 6. Every time you will get lambda is half. That is, you just have to take one of them. You know, lambda is going to be same everywhere, every time. So lambda is 1 by 2. It's 1 by 2, that is 1 is to 2. So it's internal, no negative, internal. You don't have to write internal specifically because it's obvious. But for if it comes negative, you have to specifically write external. This is question number 7. The midpoints of the sides of a triangle ABC are given minus 2, 3, 5, 4, minus 1, 7 and 6, 5, 3. Find the coordinates of A, B, C. So we just have to use the midpoint formula, that is the section formula with midpoint version. So this is, but the algebraic skills it will be employed here. Otherwise, this question has is quite easy, because this ABC is the midpoint. So let me just not take this ABC as the vertices. I'll take this as, say, D, E and F. Let me take it as D, E and F. So these are the vertices, D, E, F. Okay, x1, y1, z1, assume it to be. E, let us take it as x2 plus y2 plus z2. The F point is x3, y3 and z3. So these are the points we assume, and the midpoint is known to us. Each side, the midpoint is known as A, B, C are the midpoints. So just say A is the midpoint, B is the midpoint of one of the side, C is the midpoint of one of the side. Okay, it really doesn't matter which side it is, because D, E, F we have taken, x1, y1, z1 we have taken. So it can be anywhere. The answer is going to be same. Now ABC, A is -2 and 3, 5. This C is 6, 5, 3. B point is 4, -1 and 7. Now what you have to do, you know the midpoint. I told you the formula in the first question. M1 is 1, M2 is 1 here. That is M1, see, M1 x2 plus M2 x1 divided by M1 plus M2. M1 x2 plus M2 x1 by x1 plus x2, if you remember. So this M1 and M2 are equal, is 1. So it will be simply x1 plus x2 by this 2. So x1 plus x2 by 2 is 6. y1 plus y2 by 2 is 5. z1 plus z2 by 2 is 3. 6, 5, 3. This is how you get it. And you will do it for each of the edge. x2 plus x3 by 2 is -2. And y2 plus y3 by 2 is 3. And z2 plus z3 by 3 is 5. So the relationship which we are going to get is x1, x2 plus x3 by 2. So x2, x3 you get, y2, y3 you get, z2, z3. And you have to take the midpoint of other side, I just told you. The same kind of relationship means similar looking relationship you will get. So this is for the third one. If C you take, it will be x1 plus x2, y1 plus y2, z1 plus z2. Now how to solve this? Now you have to add all these three. Whatever you got, 3 from 3 edges, just add all of them. That is, take the x1, x coordinate, x2 plus x3, I'll just do one of these, x2 plus x3, from here you have x1 plus x3, from third one you get x1 plus x2, equals, and now add the right hand side, -4, 8, and then 12. So here we have twice x1, twice x2, twice x3. So let me take 2 outside. x1 plus x2 plus x3 will be inside. And that will be equal to 20 minus 4, that is 16. 8 minus 4, 4. 4 plus 12 is 16. So now you have 16. So, divided by 2, it will be 8. So x1 plus x2 plus x3 equals 8. Okay. Now we have 3 equations which we added. Now we'll use them one by one. x1 plus x2. Same thing you have to do with y. Same thing you have to do with z. Remember, I'm not doing it, but same thing you have to do for y and z. You'll get y1 plus y2, y plus y3. You'll get z1 plus z2 plus z3. That is first is 7, second will be 15. So let me stick with x right now. So x1, x2, x3 added is 8. How about x1, x2, x3? How to find x1, x2, x3? So take the first equation with the last equation. That is x1 plus x2 plus x3 equals 8. I am taking x2 plus x3 equals -4. So now subtract them. So x1 only will remain, 8 minus 4 will be 4. I am subtracting these two equations. So 8 minus or minus 4 will be 12. So now take this again, x1 plus x2 plus x3 equals 8. Now take the second equation. That is x1 plus x2, x1 plus x3 equals 8. Now you will get x2 from here. x2 is 8. This is x2 gets cancelled, 8 minus 8 is 0. So you have x2 as 0. Now x1, x2 you got, now x3. Same thing you have to do. You will take the third equation, x1 plus x2 plus x3 equals 8. Third equation is x1 plus x2 equals 12. So here you will get x3, just subtract this. So x3 will be 8 minus 12, that is minus 4. So you have x1, x2, x3. In this same manner, you have to find y1, y2, y3 and z1, z2, z3. These three coordinates will come. I hope you got the idea. So question number 8. Now this question and the question number 1 is almost similar. So A, B, C are the vertices of a triangle ABC. Find the point in which the bisector of angle BAC meets BC. Well, we have already done this. The concept is we have the internal bisector of angle A, which is BAC angle, and this internal bisector line, which is AD, intersect the opposite side, which is BC at D. So we have to find out the point D, this point D. So first of all, as I told you, you can find out BD is to DC. What is that ratio? So we know that BD by DC equals AB by AC, the side holding the angle, and the points or the parts which is opposite to that angle which is being bisected. So basically BD by DC will be equal to AB by AC, that is 3:1. So 3:1. Now this is 3, this is 7. Now just take the points, because you know this is a ratio. So x, y, z you can find out. So x will be 0 into 7 plus minus 1 into 3 divided by 2. This is your x point. Then minus 1 into 3 and 4 into 7 divided by 3 plus 7, second point. Minus 3 into 3 plus 7 into 1 divided by 3 plus 7 equals third point. So this is your points. Okay. Now there are 16 questions. So this question I am going to take in the next discussion. Till then, thank you so much. Take care of yourself.